Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Tenban by Chris Napolitano. And here are the rules. We have place the digits 0 through 9 once each into every row, column, and 3 by 3 box. To enable this, one cell in every row, column, and 3 by 3 box is a Schrodinger cell that contains two center marked digits. The value of these Schrodinger cells equates to the sum of those two digits. So, this is not typical Sudoku rules because, again, so how would I phrase this? I would phrase this is this is yeah, I'm kind of curious how I would phrase this. That would make it clear. So you obviously it's not normal Sudoku rules where you would basically in every cell in the grid you place a 1 through 9, a single digit from 1 through 9. Oh, there was a puzzle that I think framed it very well as a Schrodinger, but the problem is I don't remember how it framed that. I This is the reason why I chose to say place in every cell in the grid a single digit from 1 through 9. But because whoever framed the Schrodinger rule set framed it so well that I was like, this is so clear. Um, I don't remember. I'll look into it later, and then the next time we do a Schrodinger cell puzzle, I will whip that out because they explained Schrodinger cells so well that I was just like, this is a great way of explaining it. And then it led to me changing the way that I explained normal Sudoku rules because yeah, I don't know. I don't remember how it was. Someone did it really well who explained it very well. This is fine. But yeah, I'm gonna pause. I'm gonna look for that right now. Maybe we can just get it right now, and I'm gonna pause. Sorry about that. We'll be back right in a second. Okay, I'm back. I think I found the puzzle, and it was shoot. I don't remember who Juggler is. He goes by the nickname of Juggler on the Logic Masters Germany forum, and he had a great puzzle which was called Etude for a Broken Piano. And so if you look that up, that has the description. And it's basically, to put it in this context, it would basically be in every cell in the grid, place at least one digit with the digits from the digits 0 through 9, such that there are no repeats in any. No, it has to be the full set. Let me see it again. This is the puzzle here. So Etude for a Broken Piano. Let Michael Lefkowitz. Okay. And he says place one or more digits from 1 through 9 in every cell so that each digit appears exactly once in every row, column, and region. The value of the cell is the sum of its digits. This is so well written. The thing is, from this that basically, so since each digit must appear exactly once in every row, column, and region, you can only have a Schrodinger cell once in every row, column, and region. Because you have to place at least, you place one or more digits from 1 through 9 in every cell. But every cell has to contain at least one digit. That's the key, right? So therefore, since every cell in the grid must contain at least one digit, to fill an entire row with greater than the number of digits in that row, which in this case was 9 versus 8, or 8 versus 9, however you want to put it, you can only have one Schrodinger cell in every row, column, and designated region. So I love the way that he phrased this, because so I guess yeah. So you can't use the typical without repetition. Maybe yeah, I'm not sure. Anyways, the other version of this rule, so then in this, if we use that Schrodinger Sudoku rule set, we need to place one or more digits from 0 through 9 in every cell so that each digit appears exactly once in every row, column, and designated 9-cell region, which is a box. So it does use the, they must appear exactly once. I like the one without repetition, but I guess you can't really extend it there into this one, right? This one, it has to appear exactly once. Because otherwise, without repetition, could have multiple Schrodinger. Could it have multiple Schrodinger? It can't have multiple Schrodingers in it. You could just have 0 through, like, you could omit a digit. That's the problem. And so that does not guarantee that there's a Schrodinger's. So Schrodinger necessarily has to have that each digit must appear exactly once in every row, column, and 3x3 box. So I do like the way that the Schrodinger is put. I'm just, how do I extend it to normal Sudoku? I don't think I can, because I did it without repetition, because there are situations where you're okay with repetition. Um, hmm. Or you could have repetition of values, but not. I don't know. I'll have to think about that a little bit more. But okay, so the way that Michael Lefkowitz puts it, which I think is a great way of putting Schrodinger cells, is in every cell in the grid, place at least one digit in every cell from the digits 0 through 9, such that the digits 0 through 9 appear once each in every row, column, and designated 9-cell region, which is a box. And so that necessarily gives you a Schrodinger cell, which must appear once in every row, column, and 3x3 box. Because if you have multiple Schrodinger cells in a row, right? If you try to say have, I don't know why you use those as blue. It should be green, I believe. If you have multiple Schrodinger cells in a row, with the requirement that you have one digit in every cell, at least one digit in every cell, this doesn't work, right? Because then you would have 2, 4, 5, 6, 7, 8, 9, 10, 11 digits in row 1 if you had two Schrodinger cells in there. And there's only 10 digits, right? There's digits from 0 through 9. So that's impossible then to have two Schrodinger cells in any row, column, or box that way. So it necessarily reduces down to that if you say, in every cell in the grid, place a single digit, or place at least one digit from 0 through 9, such that every digit from 0 through 9 appears exactly once in every row, column, or designated 9-cell region, which is a box in this case. So you don't even have to talk about Schrodinger cells or whatever. It is a little clearer in basically saying that Schrodinger cells must appear once in every row, column, and box, but you can derive that just from the rule set that Michael Lefkowitz formulates. So, and the value of the cells equate to the sum of those two digits. Okay, so let's continue with the rules. Aside from my sort of rewriting how I think the ideal way of writing Schrodinger cell rule set is. We also have each purple line contains a set of consecutive values with no repeats. So these are Renban lines, but these are specifically for values. So, for example, if this were a Schrodinger with the value of 2 and 6, well, sorry, with the digits 2 and 6 in it, therefore this would be a value of 8, so this digit here must be form a consecutive set with that value. So this would have to be 7 or 9 with the 2 or 6. Or it could be a Schrodinger itself, which has a value of 7 or 9. So then this could be a Schrodinger of, say, like 3, 4. And this would be a valid Renban line because 3 and 4 add up to 7, 2 and 6 add up to 8. So the values of 7 and 8 are consecutive. And there are no repeat values on Renban lines. So keep that in mind. Cells separated by a white dot contain consecutive values. So similarly to Renbans, so essentially this is similar to what the dots are, right? So cells separated by a white dot contain consecutive values. So if the value of this cell were a 6, the value of the cell would have to be a 5 or a 7, but not necessarily the digits, right? Because again, we're just talking about the white dots separate cells which contain consecutive values, not digits, because of the Schrodinger cell possibility. And all white dots are given. So that means there are no, there is a negative constraint involved. So there cannot, if say this was a value, well, this is a value of 8. That means these cells cannot have a value of 7 or 9 because there's no white dot on the edge that separates these cells. And there would have to be if they were consecutive in value. So keep that negative constraint in mind. That is very important. And then finally, we have numbered rooms clues, where clues outside the grid indicate the value which has to be placed in the nth cell in the corresponding direction, where n is the digit placed in the first cell in that direction. So, this is a numbered rooms clues. This has a value of 10. So it's saying that in the 8th cell, because this is the first cell in this direction, so this must be n. So in the 8th cell in this corresponding direction, there must be a value of 10. And that actually tells you a lot of information. So that's an example of how numbered rooms clues works. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, as I said, this 8 means that in the 8th cell in this direction, it must have a value of 10. So this has to be the Schrodinger cell, or the cell that contains 2 digits. That means the rest of the row and the rest of the column and the rest of the box cannot contain Schrodinger cells. Whether it's because of defining the rules or the way that I put it, again, you have to place the digits in every cell in the grid. You must place at least one digit from the digits 0 through 9 in every cell, such that there are no repeats in any row, column, or designated 9-cell region. And therefore, it necessarily means this has to be 10 in value. That means where else can 10 be in value in row 1? It has to be in the second space. So this is a 2 here to signify where the Schrödinger cell is. Okay, so these cannot be Schrödinger cells here because they are numbered rooms clues, and you can't have a value of 10 be in multiple places on the same row. So this is not, and these are not Schrödinger values, Schrödinger cells, because they are single digits, right? That means the Schrödinger value cannot be 5, because then they would both be 5 here. So this cannot be a Schrödinger value. So it must be some combination of 3, 7, or 4, 6 here. So the number of rooms clues points to one of these. This value has to be either 1, 9, 3, 7, or 4, 6 here. And along the Schrödinger, or on the Renban line, you have to have a 10 in value. Or this is the 10 in value. So the other digits must be 9, 8, and 7. Because you can't have a Schrödinger on the same row or the same column or box, and therefore these values can't be the sum of 2 unique digits. So we know then this has to be 8. We need a 7 and a 9 here also to form a Renban, because it can only be 7, 8, 9, 10 as a value. So then this has to be a 7, 9 pair here, which means this cannot be 1, 9 or 3, 7 because of the 7, 9 pair in the row. So this is both 4 and 6 in this box. Remaining digits in row 1 then are 0, 1, 3, and 5. And this can't be 0 because of the 0 in the column. The sum of these digits have to be 1, 2, or 3. That means this is at maximum 3 here. So this is 1, 2, and 3 because this is a value of 0. And 0 must form a Renban with 0, 1, 2, and 3. 0, 1, 2, and 3 for 4 cells. Okay. These values, though, cannot be consecutive because we have all white dots are given. So if the value were 2 here, that means the other value would have to be not 2. So that means the value of 2 has to be here. And it cannot be a, how do you say it? It cannot be a Schrödinger cell because the only way to form a Schrödinger cell of a value of 2 would be 0 and 2. And we already have a 0 in the box. So this is a 2. This is not a Schrödinger. This can't be 2. So this must be a 1 or 3 as a digit. Can it be Schrödinger? No, because Schrödinger, to have a value of 1, would have to be 0 and 1. Can't be that. To have a value of 3 would be 1 and 2, or 0 and 3, and it can't be that. So this is not a Schrödinger. Therefore, this cannot be 3 here, because that would force this to be a Schrödinger, which it's not. This can't be 7 anymore. This is 1 or 3. If it's 1 here, this can't be Schrödinger either, right? Say this was Schrödinger. We tried to make this Schrödinger. That would be 1 and 2, which would add up to 3. Because you don't have a 0 in that row. And that would force this to be 3. Because you already have a 1 and 2 in this box. So this cannot be Schrödinger. This must then be a 1, 3 pair in this box here to be a Renban of values. So this cannot be 3 and 7 anymore, and this can't be Schrödinger because we can't be 3, 7 because of the 1, 3 pair in the row. Wait. Oh, yeah. Okay, that works. So it has to be 4 and 6, and this has to be 4 away from this way. So this is 4, and that's 6. Therefore, this is not a Schrödinger. This has to be a Schrödinger here. Cannot have a value of 1, 9, 3, 7, or 4, 6 This has to be 2 and 8 to add up to 10. So this is a Schrodinger, which eliminates Schrodingers in the rest of the box and the rest of the column. Remaining digits in row 9 are 5, 7, and 9. So 5, 7, and 9. Okay, this is 4. Ten. 10 cannot be consecutive with a value of 9 because there's no white dot between them. So this must be 7, which makes this 9. This cannot be 7 here. If this were 1, the problem is you would guarantee a 0 in the 2 cells next to it, and there's no white dot there. So then that would be consecutive, which is not allowed. So this cannot be 1. These digits are consecutive. Where is 2 in row 7? Cannot be here because of the 2 in the box. Can't be here because of the 2 in the box in the 2-8 pair of the Schrodinger. And cannot be consecutive with a 1 because this would then be 2 guaranteed as a single digit because we have a Schrodinger in that column. So 2 has to be here either as a Schrodinger or as a normal cell. We're not sure which. That means where is the 2 in column 2? Can't be here because of the 2 in the box. Can't be here because of the 2 in the box. So it has to be one of these 3 digits there. We don't know if this is Schrodinger or not, though. Okay, remaining digits in row or box 9. We have 1, no 0, 2, 3, 4, 5, no 6, 7, 8, or 9. 1 and 3 could be any of these. So 1 can't be here. Okay. This can't be 8 because of 8 in the column. This can't be 1 because of 1 in the row. So the question is, where can the Schrodinger be? 8 has to be in one of these 3 cells here. 8 can either be with 1 or 9, 1 and 8 to form a Schrodinger, a value of 9. It could be 1 and 8 adding up to 9. 2 cannot add up with 8 though because we already have a 2 in the box. If it's 3 and 8, that would be a Schrodinger value of 11. But the problem is that then there would be no Schrodinger value of 10 to be with that in that box because, again, we already have the 8 would be in a Schrodinger value of 11. So the only possible Schrodinger that 8 could possibly be with is 1 and 8, which adds up to 9. But if we have 9, we've already used the 8, so there is no other 8 in value in that box, which it would have to be consecutive with the 9 in value of that. So the 8 must be a single digit in this box, and it must be next to a 7 or a 9 in value. Interesting. This is a 10 in value, and if this is a 9, that would be a 9 in value, and that would be consecutive with that. And 9 cannot be either of these spots, so 9 has to be here. So this is 9, which makes this 5, which makes that 7. So none of these... Okay, this 1 cannot be consecutive with a 0. So this has to be a 3, which makes this 1. Because there are no consecutive values except for in the white croppy dots. This is the negative constraint I was talking about. Therefore, where is the 1 in row 8? It has to be one of these 2 digits. And 3 cannot be here anymore. Well, since 1 is one of these 2 digits, it has to be as a Schrodinger cell. If it were not a Schrodinger cell, the 2 and the 1 would be next to each other without a white dot in between them, and that is not allowed. So one of these two is a Schrodinger cell, which means this is not a Schrodinger cell. And 8 cannot be, well, 8 could be here if this is the Schrodinger cell. So one of these two is a Schrodinger cell, which means this is not, whereas the Schrodinger cell in row 7, it has to be here, as I said. So that means this is not just a 2. This is a 2 with something else, and we don't know what it is. Remaining digits in box. Okay, so this, remaining digits in box 8 are 0, 3, 4, 5, 6, and 9. 5 cannot be on this Renban, because that would be 5 in value. 0 cannot be here on the Renban. 9 cannot be here on this Renban. We are guaranteed a 4 on this Renban, because, again, the Schrodinger cell is here, so this must be just the value of the digit. And it has to be 3, 4, 5, or 4, 5, 6 here. So 4 cannot appear in the rest of the box. 9 cannot appear here because of a 9 in the column. So 9 is one of these digits. This cannot be 0 because that would be consecutive with 1. This can't be 6 because that would be consecutive with 7 without a white dot between them. One of these is 4. So 5 cannot appear in either of these cells because, again, they would be adjacent to a 4 without and being consecutive with that. So this cannot be 5. Actually, this can't be 3 either, because if this was 3, it would be definitely consecutive with 4 here. So we know 5 has to be one of these two digits here. If this, that could be 6, but this could be 0, 9. 0 is one of those 3. So we have 1. Interesting. Okay, 6. This could be 1 and 5, potentially. This cannot be a 4 by itself, but it could be 1 and 4. Okay, what are the remaining digits in box 7? We have 0, no 1, 2, 3, no 4, 5, 6, 7, or 8. 7 cannot be either of these. 8 cannot be either of these. Next to the 4 cannot be 3. Next to the 9, we already have an 8, possibly. Next to the 5 cannot be a 6. Next to the 1 cannot be 0. This 3 eliminates 3 here. Okay. What else do we have? These digits must be consecutive. And neither of these can be 9, because that would be next to an 8. Let's just look at the remaining digits in box 1. We have 0, 1, no 2, 3, no 4 or 6, 5, no 7 or 8, 9. This has to be a 0, 1 pair, because there's no other consecutive digits here possible. So this is 0 and 1, which eliminates 0 and 1 in the rest of the box. This can't be 1 because the 1 in value would be consecutive with the 2 and adjacent to it, and there's no white dot there. So this is 0, this is 1. 9 cannot be next to the 8, so this can't be 9 here. So we have a 9 guaranteed in one of those two cells. This 4-6 pair eliminates 6 in the rest of the column. Okay. 2 is one of these 3. Cannot be here because that would be consecutive with the 1. Remaining digits in column 2, we have 0, 2, 3, no 4, 5, no 6, 7, no 8 or 9. This can't be 0, 2 because that's consecutive with 1. 2 has to be one of these two. 5 is one of these three. Okay. Remaining digits in column. Okay, so this Schrodinger eliminates Schrodinger in the rest of the column. Remaining digits in column 1. We have no 0, no 1, no 2. Could be 3, no 4, 5, 6, 7, 8, or 9. Okay. And one of these is a Schrodinger. We don't know which. Okay. 2 is one of these two. That means 3 cannot be the other digit here. So this can't be 3. Right. Okay, so that's fine. This is a 5, so this cannot be 5 here. The values of this is at most 5, 6, and 7. So this is at most a 7 here. This can't be 0. This can't be 1. 8 has to be then one of these two digits here. And it cannot be here because of the 2, 8 in the Schrodinger cell there. So this must be 8. Interesting. This can't be 7 because of the 7 in the column. This 1 eliminates 1 in the rest of the column here. So this is 8. 8. Ooh, could be Schrodinger actually too as an 8. We don't know it's an, so that's 8. Could be Schrodinger. That means this is at least value of 7, but this could be Schrodinger also. So there's no limitations there right now. The value here, though, must be at least 7. Okay. Remaining digits in column 4. We have 0, 1, no 2, 3, 4, 5, 6, no 7 or 7, no 8 or 9. This can't be 0 because of the 0 in the row. This can't be 1 because of the 1 in the row. 9 has to be one of these three. Oh, that's interesting. Hmm. These are consecutive, these are consecutive. So we probably need to look at this part here. Can it be two sets of consecutive digits? Yes. So we're not guaranteed that the 1 has to be here. Right? It could be 4, 5, or 8, 9, or 8, 7. That would be fine. The 1 and the 9 cannot be a Schrodinger together unless it's here. In which case it would be. Huh. Interesting. This cannot be a 9 by itself, because that would guarantee you need an 8 somewhere on this Renban line. And neither of these could be 8 because of the 8. I guess it could be Schrodinger. Well, no. If this is 9, I guess one of them could be Schrodinger. Never mind. So that's not as restrictive as I thought it would be. Does 1 work actually with anything else as a Schrödinger? Sorry, as a consecutive digit. I don't think so, right? 1 and 5 could be with 7. That's the only way that it works then. Okay, so that's possible. Hold up. This is 10 in value. So yeah, let's look at row 9. 4 and 9 are not consecutive, 9 and 5 are not consecutive, 5 and 10 are not consecutive, 10 and 7 are not. 7, 1, 1, 3, 3, 0, 0, 6, 0, 2. Okay, one thing that okay, so if the 1 and the 5, so the only, okay, 1 and 4 would add up to a sum of 5, but 5 is not consecutive with any digit. So that doesn't work there. 1 and 5 add up to 6, which is consecutive with 7, so that could work. 1 and 7 add up to 8, which is only consecutive with 8 out of the remaining digits. And, sorry, it's not even consecutive with 8 out of the... Oh, 1 and 7 could be worked with 9. Ah, but then 8 wouldn't have any consecutive digit to be consecutive with, right? Because you would have 1, 7, and 9 be consecutive with each other, but then the problem is 8 would not have a 7 or 9 to be consecutive with in the other set. So 1 and 7 does not work. 1 and 8 adds up to 9, but then that's only consecutive with 8 as a digit, which we already used. And 1 and 9 add up to 10, which is only consecutive with 9 as a digit, single digit, which we already used. So, if this were the Schrödinger, it would have to be 1 and 5 here, which would make this a 7. This would have to be an 8-9 pair to be consecutive here, and that would force us to be 4. But the problem is that would eliminate 4 and 5 in the rest of row 8. So where would the 4 and 5 be in box 8? It would have to be here and here, and they would be consecutive digits adjacent to each other without a white dot in between. So that's a contradiction. So this cannot be a Schrödinger, and the 1 has to be a Schrödinger here. So this cannot be 1. This is either 4, 5 as a pair. Or it's 8 here with 7 or 9. So this cannot be 7 or 9 here. This is either 8 with 7 or 9, or this is a 4, 5 pair. Interesting. This is 1. It cannot be with 4 or 5, because if it's with 4 or 5, we can't have 2 sets of consecutive digits here then. So it's only with 7 or 9 here. And we're guaranteed a 1 is here, so we don't know where the other one is. Yeah, this is an 8. We don't know if it's a singleton 8 or if it's a Schrödinger 8. The rest of this column cannot be Schrödinger because of the Schrödinger cell in the column. We don't know if it's 7 or 9, though. Let's see. If this were 4, that means this could not be 5 because of the white dot negative constraint. This would not be 4, so this would have to be 4, and that would be 5, and we'd have the same contradiction. So this cannot be 4 here, which means this can't be 5. So 4 has to be one of these 3 cells here, right? So again, if this is 4, this can't be 5. That can't be 4, so this must be 4 and 5 in box 8, and that's a contradiction. And because of the negative constraint for the white Kropke dots, that can't occur. So 4 has to be one of these digits, which means this cannot be 4. So this must be a 4 here. This is a 1. One of these is a 5. So since one of these is guaranteed to be a 5 in row 8, this cannot be consecutive with it. So this cannot be 6 here. So 6 in, where is the 6 then in row 8? It must be here. So this is 6, which eliminates 6 here as a possibility. Where is 7 then in, actually this 6 eliminates 6 here in the rest of the row. Where's 7 in box 7? It must be one of these 2 digits here, which eliminates 7 in the rest of the column. We're guaranteed a 6 there. One of these digits, this could this be 9? Maybe. So this is going to be a value of 8 or 10. Oh. Well, if it's 10, it's fine. If it's 8, that does not work. Well, if this is 4, 5, it does. Interesting. Huh. Okay, this 4 eliminates 4 in the rest of the column. We are guaranteed a 7 here and an 8 here, but one of them could be in a Schrodinger cell. Or both of them could be in the Schrodinger cell. So we don't know anything about that. This 5, this 5 eliminates 5 in the rest of the column. This can't be 5, so this is 3. This can't be 3 or 5, so it's 9, which forces this to be 5. So 5 cannot be here. Okay, that's helpful. This eliminates 3 in the rest of the column. So where's the 3 in? This has to be a 3-7 pair here, which eliminates 3 and 7 in the rest of the column. So this can't be 3. This is 5. These can't be 5. This becomes a 0-2 pair. What are the remaining digits that in column 3? This is 0, 2, and 8 as a possibility. So that so this is either 0, 2 here and 8 here, or 8, 2, 8 here and 0 here. So that means this has to be 1, no 0, 2, no 3. It could be 4 or 6. This is 1, 4, or 6. Well, this digit cannot be 4 or 6 because that would be consecutive with the 5 with the negative constraint of the white Kropke dot. So this is 1. These can't be 1. It's a 4, 6 pair. This one eliminates 1 here and a 0 because that would be consecutive with the 1 without a white Kropke dot in between. Say we had the 8 here. That would force this to be a 0, 2 Schrodinger, which would make this 6, that 3, and this 7. So that works. If this is 8 here, that would be 0, 9, interesting. Um, so 8 can be here or here. 4 is definitely one of those 3. Uh, what digits can this be, I guess? If this is 5, this has to be 7, 8, 9. Which would mean this is a 4, 5 pair. That doesn't change anything. If this is 5, so let's see what happens there. 5, 4, this would be 8. That would be 7 or 9 here. So this could not be 8. This would have to be 0 or 2. That would force this to be 6, which forces this to be 3. Forces that to be 7, which makes that a 9. So then this would be 5. And we'd have a contradiction. Oh, yeah, that makes sense. Okay. Right, so this can't be 5, because if this were 5, that would force this to be 4. This could no longer be 5, so that would be 5, and that would be consecutive with each other and adjacent, without a white dot between. So this cannot be 5, which means this can't be 4. This has to be a 4, 5 pair here. That eliminates 4 and 5 in the rest of the row, so this can't be 5. Therefore, this is 5. This digit cannot be 6, because if it were 6, that would be consecutive with 5, without a white crop key dot between. If this were 8, this cannot be 7, so it would be 3, and this would be 7. So 8 is guaranteed to be here. If this were 9, that would force this not to be 8. So then this would have to be 8 here. Where is the 3 in box 8? It must be one of these two digits here, which means that we can eliminate 3 in the rest of the row. So this cannot be 3. This must be 7, which makes this 3. That means this cannot be 7. So one of these two is a 7 here. We don't know which. These digits cannot be 5, because that would be next to a 4 or 6, which are consecutive with, without a white dot in between. This can't be 5 because of a 5 in the row. This can't be 5 because of a 5 in the row. This can't be 5 either. Where is the 5 in column 4? Again, cannot be here because it would be next to a 4 without a white dot in between. Can't be here because it would be next to a 4 or 6 without a white dot in between. Can't be here because of 5 in the row. Can't be here because 5 in the row. It has to be here. So this cannot be 5 here. That means 5 has to be one of these two digits here. This 5 eliminates 5 in the rest of the row. This 3 eliminates 3 in the rest of the row. 5 cannot be here, so 5 has to be one of those two digits there. Remaining digits in row 2. We have 1, 2, 4, 6, 7, and 9. This can't be 2 because of the 2 in the column. Can't be 6 because 6 in the column. Okay, this is guaranteed to be 8, and it could be added with something else. And this could be added with something else, we don't know. 1, where's 1 in column 4? Cannot be either of these two. Can't be any of these two. So it has to be one of these two, which means 0 could not be here because that would be consecutive with the 1 without a 1 being in between. Without a white dot in between, I should say. So 1's guaranteed to be here. So 1 in column 5 has to be one of these two. And it could be here as part of a white Kropke dot. This can't be 6 because of it's next to a 5. And that would be next without a white dot in between. Hmm. 8 has to be one of these 3 cells here. This can't be 7 because of the 7 in the column. So 7, where's 7 in? Oh, it could be here. I was hoping it had to be one of those. Wow, it was looking like it had to be one of those two, but not actually. This cannot be 7. It could be, actually. Huh, never mind. Huh. Remaining digits in this box or cell can be 0, 2, 3, 4, 6, 7, 8. Oops. We know there's an 8 already there. It could be a Schrödinger. Okay, remaining digits in row 3. 0, 2, 3, 4, 6, 7. No 8. This can't be 0 or 2 because of the 0, 2 in the column. Oh, this can't be 1 because of the 1 in the column, definitely. Remaining digits in, this can't be 6 because of 6 in the column. Remaining digits in column 9. We have 0, no 1, 2, 3, 4, 5, no 6, 7, no 8, or 9. Can't be 5 because of 5 in the row. If this were 0, that would not have a value of 1 in either of these cases. So this cannot be 0. This cannot be a 4 or a 5 because that would be consecutive with this digit here, which would also be a 4 or 5, and they would be adjacent to each other without a white dot between. So 5 cannot be either of these digits. Can't be here, can't be here, so 5 has to be one of these two. Interesting. 0 is one of these three. That doesn't help us much. These two digits must be at most 2 away from each other, which they are. You cannot have 7, 9, and 7, 9, though. So this cannot be 7, 9 as a pair. Because these are at most 2 away from each other. And if this is a 7, 9 pair, that eliminates the extra digit here on the Schrödinger. So this cannot be 7, 9. It's some combination of 2, 3, 2, 4, or 3, 4. So this cannot be a Schrödinger. This can't be 6 and 7 in value. That means the 2 has to be one of these two. And the other one is, so this can't be 9. We have 2, 3, and 4, and they're all non-Schrödinger because this can't add up. Therefore, this can't be 2, 3, or 4 because it must be different 2, 3, and 4 digits. 07. This cannot be 2 again because of the 2 in the column. One of these is guaranteed to be 2 with 3 and 4 here. Okay, what else do we have? Can this ever be 0? The answer is no. This can't be 1 in value. This can't be 1 in value. So therefore, this can't be 0. Can this be 1? It could be 1. Where actually is the 0 then in row 1? It has to be one of these two digits, which means this cannot be 0. If this were 1, that would force this to be a 0 here, which would be a contradiction, which if this is 1, that guarantees 0 has to be here, and they would be adjacently, they would have an edge between them without a white Kropke dot, and they would be consecutive, which is not allowed. So this cannot be 1. So this becomes a 0, 3 pair, which eliminates 0 and 3 in the rest of the row. This becomes a 1, 5 pair, which eliminates 1, 5 in the rest of the, box. Yeah, the 0, 3 pair eliminates 0, 3 in the rest of the box, too. So no 0, 3, no 0, 3. This can't be 0, 3. It must be 7, which eliminates 7 in the rest of the column. This is a 1, 3, 6 triplet, then, which eliminates 1, 3, 6 in the rest of the column. Therefore, this can't be 6. That's 0. This 0 eliminates 0 here, so it's 9. This can't be 0 or 9, so that's 3, which makes this a 6. 0 eliminates 0 here. This becomes a 2, 8 pair. That forces this to be 0 here. This can't be 8 anymore. It's 9, which makes this 8, which makes that a 1, 7 pair. That eliminates 7 in the rest of the column. This can't be 7. That's 0. So no 0 or 7. So one of these is 9. We're not sure which. 0 cannot be next to 1. So where's the 1? It has to be here. 7 cannot be next to 6. So this is 3 and 6. All because of the white Kropke dot negative constraint. These can't be 7 anymore. This has to be a 1 in some way, but it could be the Schrödinger, so we don't know. This is guaranteed 8. There's no more 1 or 5 in the rest of box 3, but we already knew 5 there. 1 has to be in one of these two cells here. This 6 eliminates 6 here, so it's 4 and 6. That means 6 has to be one of these two cells in row 4. This 6 eliminates 6 in the rest of the column, so it cannot be 6. So 6 has to be one of these two. We know 8 is there. What else do we have? So one of these 3 digits is a 4. One of these 2 digits is a 4. That eliminates 4 in the rest of the column. So this cannot be in the rest of these 2 columns. So this cannot be 4 here. This cannot be 4 here. This cannot contain a 3 in value. There's no 1 possible in these 2 spots. And 3 cannot be here because of the 0-3 pair in the box. So you can't have 1, 2 adding up to 3. You can't have 3 by itself adding up to 3. So this can never be 1. This is 5. That's 1. You cannot have two Schrodinger cells here, or even 1. If you try to have 1, that would be minimum 2, 4 added together, and then you have a 6 there. So this must be non-Schrodinger cells, which means this has to be 4 and 6 to add to be a Renban in value. So this is 4, that's 6. This cannot be 4, this cannot be 4 or 6. So the 2 is one of these. We don't know which. This cannot be 1 and 2 as a value in a Schrodinger because that would be consecutive with 4. So this has to be just 1 by itself, which means this is not a Schrodinger. This is a Schrodinger and is a 10. 10 has to be consecutive with either 2, 9. This can't be 6 here. It could be 2, 9, 4, 7, or 9 by itself. So any of those work. This can't be 0 or 2, or 4 or 7. This 4 eliminates 4 here, so that's 3, which means this can't be 3. This is a 2, 4 pair, which eliminates 2 and 4 in the rest of the column. So this can't be 4. This is 5, which makes that 4. This can't be 5, so this becomes a 3, 9 pair here. This 3 eliminates 3 here, so it's 6 as a single digit and non-Schrodinger. Either of these could be Schrodinger. 2, 9 works, 4, 7 works, 9 by itself works. So, and this 9 eliminates 9 here. So this has to be a Schrodinger. And it must add up to either, it could be 9 or 7. So this is 7 with 2 or 4. This is 9 and not a Schrodinger. So this is a Schrodinger here. It's 7 with 2 or 4. We don't know which. 6 cannot be here, so 6 has to be here. This has to be Schrodinger. 7's guaranteed here. Remaining digits in column 8. We have no 0 through 4, so it could be 5, 6, 7, or 8. Interesting. This can't be 5, this can't be 6. If you have a 6 with a 7 here added together as a Schrodinger, that's too much. That's 13, which a single digit cannot be added up to. If this was a Schrodinger, you'd have the same problem. Because 5 and 7 add up to a minimum of 12, which a single digit cannot be, which actually this would have to be 6. So this is 6 as a non-Schrodinger. This is a non-Schrödinger, and it's 5 or 7. This must be 8 with 5 or 7 here. That means the remaining digits, this cannot be 1. This has to be a 1 here, which must be consecutive with 2. So this can't be 2. This is 4 and 7 as a pair. That leaves the remaining digit as a 5. No, 1, 2, as a 0. Apologies. So this is 0. This 3 eliminates 3 here. This 2 eliminates 2 here, so it's 4, which makes this 2. Okay, 5 and 7. 5, 7, 8 as a Schrödinger is fine. So this is a Schrödinger, which eliminates Schrödingers in the rest of the row. This is 6. This cannot be Schrödinger because of the Schrödinger in the column. This has to be 5 or 7 to be consecutive with it. It can't be 5 because of the 5 in the row, so this is 7, which eliminates 7 here. This has to be 3 or 7. I guess 3 and 7 could be here as a pair. This 2 eliminates 2 here, so that's 0 and 2. This has to be 2, 8, or 9, and it cannot be 9 because of the 9 in the column. Where is the 9 in row 4? It has to be here, so this eliminates 9 in the rest of the box. But this could be Schrödinger, this could be Schrödinger. 2 cannot be here by itself, and it's guaranteed to be here. And that would be consecutive with 3 without a white dot in between, so this must be Schrödinger. Which means this cannot be Schrödinger. This is Schrödinger. This is not Schrödinger. This must be a 9. This cannot be 3 by itself because it would be next to a 2. So this cannot be 3. So this has to be 3 and 7 or 3 and 8. If this is 3 and 7, that would add up to 10, which is 1 away from 9, and there's no white dot between. So this is 3 and 8, which forces this to be 7. That eliminates 7 here. This becomes a 5, 8 Schrödinger, which means this can't be 5, that's 7. This 3 eliminates 3 here, so it's 9 and 3. These digits have to be 5 and 4. That's the only digits remaining. So this is 5, that's 4. This can't be 5. This is 2, 8. This 3 eliminates 3 here, so it's 0 and 3. That leaves this digit as a 0 and this digit as a 9. And that's the solution. Pretty cool, actually. I love Schrödinger cell puzzles. It's a very interesting, it's very interesting in general. And it's a nice little wrinkle to things. I seem to see them fairly well. So the possibilities that... So I usually don't make very many mistakes on Schrödinger cells, I don't think. Let's just check these. 2 and 10 are not consecutive. So we have... Okay, let's look at the Renban values. 7, 8, 9, 10. 4, 5, 6, 0, 1. 10, 11. 2, 3, 4, 6, 7. 4, 5, 6, 0, 1, 2, 3. Now let's look at rows and columns to make sure that they're not consecutive. I guess we could just look at 2 is not consecutive with 0 or 10. 10 is not consecutive with 2, 8, or 7. 7 is not consecutive with 10, 3, or 9. 9 is not consecutive with 7, 5, or 3. 3 is not consecutive with 9, 1, or 0. 0 is not consecutive with 3, 6, 5. 5 is not consecutive with 0, 11, and 1. 1 is not consecutive with 5, 8, 9. 8 is not consecutive with 1 or 2. 2 is not consecutive with 8, 0, or 9. 9 is not consecutive with 1, 2, 3, or 11. 11 is not consecutive with 5, 6, 6, or 9. 6 is not consecutive with 11, 10, 1, 0. 1 is not consecutive with 3, 4, 5, 6. 5 is not consecutive with 1, 7, 3, 9. 3 is not consecutive with 5, 7, 8, 9. 8 is not consecutive with 10, 0, 1, or 3. 0 is not consecutive with 2, 8, or 5. 5 is not consecutive with 0, 1, or 9. 1 is not consecutive with 5, 5, 8, and 9. 9 is not consecutive with 1, 1, 3, 7. 7 is not consecutive with 3, 4, 5, 9. 4 is not consecutive with 1, 7, 10, 10. 10 is not consecutive with 4, 6, 6, 7. 6 is not consecutive with 10, 11, 3, 0. 3 is not consecutive with 0, 6, 6, 9, and 0 is not consecutive with 2, 3, or 4. 4 is not consecutive with 0, 6, 9. 6 is not with 0, 3, 4, 7. 0 is not with 2, 6, 6, 7. 7 is not with 0, 4, 10, 10. 10 is not with 3, 4, 5, 7. 3 is not with 1, 1, 7, 10. 1 is not with 3, 5, 6, 9. 5 is not with 0, 1, 1, 9. 9 is not with 5, 5, and 11. 11 is not with 0, 9, 7. 0 is not with 11, 2, 5, and 6. 6 is not with 1, 1, 0, 4. 1 is not with 3, 5, 6, 6. 5 is not with 0, 1, 4, 10. 4 is not with 2, 5, 7, 9. Oh, this is consecutive because there's a white dot between. I was going to say. But it's not with 2, 7, or 9. 2 is consecutive with 1, not with 0, 4, 7. 7's consecutive. Oh, I've missed the 6 here. 6 is consecutive with 7. Ooh. Anyways, 7's consecutive with 6, but not with 2, 9, or 13. 9's not consecutive with 3, 4, or 7. 3's not with 5, 13, and 9. 13's not with 1, 3, 4, 7. 1 is consecutive with 2, but not 9, 9, and 13. 9 is not with 0, 1, 3, 4. 0 is only consecutive with 1. 6 would be consecutive with 7 or 5. 4 is consecutive with 3 or 5. 2 is consecutive with 1 or 3. 7 is consecutive with 8 or 6. 1 is consecutive with 2 or 0. 7 is consecutive with 5 or 8. 10 is consecutive with 9. 0 is consecutive with 1. 6 is consecutive with 5 or 7. 3 is consecutive with 2 or 4. 9 is consecutive with 8 or 10. So it is there. 4 is consecutive with 3 or 5, which it is there. 5 is consecutive with 4 or 6, which it is there. 8 is consecutive with 7 or 9, which none of them are. 2 is consecutive with 1 or 3, which none of them are. 8 is consecutive with 9 and 7, which none of these are. 5 is consecutive with 4 and 6, none. 9 is consecutive with 8 or 10, none. 4 is consecutive with 5 and 3, none. 0 is consecutive with 1. 3 is consecutive with 2 or 4. 6 is consecutive with 5 or 7. 4 is consecutive with 3 or 5. 9 is consecutive with 8 or 10. 5 is consecutive with 4 or 6. 10 is consecutive with 9. 7 is consecutive with 8 or 6. 1 is consecutive with 2 and 0. 3 is consecutive with 2 and 4. 0 is consecutive with 1. And 6 is only consecutive with 5 or 7, and this is 8. Yeah, so that's the solution. Pretty cool, as I said. I like Schrödinger cells a lot because it's a lot of interesting logic that you have to go through. But I seem to see it fairly well. So for me, it's I really enjoy them. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.